All right. Hey, everyone. Welcome to Kotlin London. A really big welcome to all the recent new joiners from around the world. It's really great to see the audience growing every month. So thank you. And everyone who's joining from previous meetups, again, welcome. If you haven't already, please join the meetup page, hit the subscribe button on YouTube, follow us on Twitter as well. And if you or someone you know might be interested in giving a talk, please let us know. We'd love to have new speakers. And if you want to try a talk, you're very, very welcome. So thanks, first of all, to 47 Degrees for sponsoring Kotlin London. Please check out the training courses in Kotlin and functional programming. And that's linked in the description below. And also, if you want to get into streaming yourself, we think that StreamYard's actually a really great platform. So to help you get started, there's a discount referral link in the description. And if you sign up for a subscription, we'll get a discount, and that'll help us reduce our costs as well. So we've got two great talks from Daniele Baroncelli and Mohit Sarveiya. First of all, obviously, a big thank you to them for joining us tonight and sharing their knowledge. It's always a pleasure. And as usual, we'll hold a short Q&A after each talk. So if you have any questions during the talk, please post your questions in the Slido link, which is shared in the YouTube chat. And obviously, of course, when you're giving a talk online, it's really hard to know how engaged everyone is in the audience. So as usual, please share encouragement, emojis, little short feedback, as the speakers can also see some of that when they're giving their talk. So it really helps them sort of gauge the pace of the talk as well. So without further ado, I think we can get started with Daniele. So please take it away.
I can hear you.
Yeah. Hello?
Oh, you can go, Daniele.
Oh, okay. Hello, hello everyone. Thank you for having me here at the London Kotlin meetup. My name is Daniele Baroncelli, and I'm going to go through this presentation about the D-KMP architecture. It's going to take around 45 minutes, and at the end, we're going to have questions, if you have. And so, what is the D-KMP architecture? D-KMP, where D stands for Declarative UIs and KMP stands for Kotlin MultiPlatform. And so it's an architecture that combines Declarative UIs and Kotlin MultiPlatform, but it's adding a third ingredient, which is the MVI pattern. So let's start. Before starting, actually, we are going to have a very quick one-question survey, and you can access this. It's just a very simple multiple question survey where we ask which is your background in terms of technologies you've built up with. So this is going to be very useful and interesting to see the background of everyone. So you can access this form either by clicking on the link, and I ask Amar to help me to post the link in the chat in YouTube and in Slido. And or otherwise you can access with the QR code by scanning with your phone, whatever you prefer. So I will wait another 10 seconds, and then we can actually show the results live. So interesting. So we have 24 responses, and we can see that basically all of you have experience with Android, and some of you have experience with iOS and JetpackCompose, SwiftUI, MVI pattern. That's interesting, and some even with GraphQL. Okay, so now we can start. Now that we get the background of everyone, we can start this presentation. Okay, so go back to the presentation. Okay, so app development traditionally has been about developing app without sharing any code. So if a company wants to develop apps in Android, iOS, and web, typically they would develop 3 whole apps. And this is a lot of effort, but is also, 3 whole apps also means 3 times bugs. And hopefully the future is not going to be like that. It's going to be quite different. And today with the D-KMP architecture, we're going to present this architecture, which will allow to share 85% of the code, where 85% is the business logic and 15% in each platform, it would be the UI layer, which is the only platform-specific code that you would have in such platform. And also in terms of development effort, you can see that it could be less than half effort of developing 3 whole apps. Let's explain some elements, some characteristic of this D-KMP architecture. So as we saw already in the diagram, we can see that the business logic and the UI are fully decoupled. And we only share the business logic, which is, by the way, the biggest part of the app, which we will show it's 85%, which is sounds like a very high number, but we're going to show why we are able to share so much. Because basically, we are able to share the view model in the Kotlin MultiPlatform. And we're going to talk about more detail in the next slides. And we are not sharing the UI. And by not sharing the UI, we are gaining the flexibility of targeting any kind of device of the present, but also of the future. And this is something very different than Flutter and React Native, where you actually lock yourself into a specific UI framework. So just to make an example, the new Harmony OS we expect that by Huawei that we expect is gonna be released and for production very soon. We expect they're gonna have their own UI toolkit. So if you develop an app with D-KMP architecture, if we go back to the diagram, we can see we are able to reuse that 85% of business logic. And in case, well, we still don't know much about this Harmony OS, but in case they have their own UI toolkit, which is different from JetpackCompose or Android, we just need to add on top just the 15%. So if you compare this with Flutter and React Native, you would not really have this kind of flexibility. And this is really one of the big selling points overall of the Kotlin multi-platform, because we don't make choices in terms of the UI toolkit. So let's go to see which are the 3 pillars of this D-KMP architecture. We already mentioned them. So it's declarative UIs, which is something which is really fresh news on mobile. We know that JetpackCompose and SwiftUI are a very recent addition to the mobile frameworks. And we are going to talk more in detail about that. Then the second pillar is the Kotlin MultiPlatform, which is a multi-platform technology, which finally makes sense and works. And we're going to talk in detail about that too. And then the MVI pattern, which is based on unidirectional data flow and a single source of truth for the app state. And is not based on RxJava. Like if you, on internet, on the web, you might find a few, most of the articles about MVI, they are about RxJava. And in this D-KMP architecture, we are showing how we are able to implement this MVI pattern on a multi-platform level based on elements of the Kotlin language. And before I start the presentation, I want to thank the people who have done a lot of research already on these 3 topics, MVI, Kotlin multi-platform, and declarative UIs. And in this presentation, what I'm doing is connecting the dots between all this knowledge that have already been researched. And I'm with this thing, I'm going to put them together and explain the D-KMP architecture, which is like the result of all this knowledge that I gathered. Okay, so this is a very simplified diagram trying to explain how app development has been in the past and how we foresee is going to be in the future. So in the past, we had a client which was based on imperative UIs. So with the term imperative UIs, we are meaning the classic traditional Android view-based UI toolkit and the interface builder on iOS. So in both of these frameworks, Android and iOS, in the imperative UI framework, in the classic frameworks, when we were to connect the UI layout to data coming from the view model, we always had a layer of code in the middle. And this is the layer of code that was able to connect by ID the data to the layout component. And find view by ID is what allowed this. So in the future, we are not going to have this kind of layer because declarative UIs don't even have IDs, and you are able to apply data directly on the UI layout without having to this kind of boilerplate code, which needs to component by component need to couple the IDs to connect the data to. This is a very important difference that we're going to see in the future, thanks to these declarative UIs. And another element, which is very important, obviously, is the ability to share a lot of code, which in the past we wouldn't. As we mentioned at the beginning, we tended to have apps which were whole apps with no shortcodes between the platform. So in the future, we are going to show in this presentation, thanks to in this D-KMP architecture, we are able to share up to the view model. And because we are able to share everything in the client to such a degree, we have the privilege and the opportunity to move more logic into the client. So we can develop an architecture that is rich client, which is something that in the past, it would have been very expensive, because any logic that you put in the client in the past had to be replicated on every platform. And by using a multi-platform approach, we don't need that. So we just write once any client logic, and automatically that can be applied to all platforms we write the apps for. So let's do a very quick recap of what we said, of what we believe is the difference between the past and the future. So in the past, we had a UI layout and view model, which required a coupling middle layer to connect each other. In the future, the UI layout and the view model are going to be fully decoupled. In the past, we used not to share any codes in the client, or typically no code. And in the future, with this D-KMP architecture, we will be able to share 85% of the business logic. In the past, we had we were using patterns like MVCs, MVP, or MVVM. And in the future, we will see how it makes a lot of sense to use a pattern like MVIs, because it's like perfectly, it fits perfectly with the declarative UIs. And MVI, thanks to this single source of truth for the app state, we're going to talk about this in the next slide. So this is just, beginning an introduction to the concept, but we will develop further. And then, as we said, in the future, we have the opportunity to use a rich client architecture. And a rich client architecture, it really reveal in a better user experience, because the more logic you're able to put in the client, then you can really create some very smart logic, which can improve in most cases, the user experience a lot. Okay, so one very important thing to say about the D-KMP architecture is that it's aimed to greenfield projects. So D-KMP architecture is not about gradually introducing declarative UIs and KMP to existing projects. You can use KMP, Kotlin MultiPlatform, in many different ways. You can also use KMP for sharing a model between platforms without really affecting anything in terms of architecture. So D-KMP architecture is really about a clean, solid, future-proof architecture which is making no compromises with the past. Very important also to highlight that it is not a library, the D-KMP architecture. So it's an architecture and is fully relying on the official frameworks. And we are going to talk about, JetpackCompose, SwiftUI, and the whole Kotlin multi-platform technology. Okay, let's now talk about the first pillar we already mentioned, the declarative UIs. Let's give a short timeline, quick timeline. So declarative UIs became popular on the web thanks to RxJS, which is a framework created by Facebook in 2011, which was open source in 2013. But on mobile, it arrived a little bit later, first of all with React Native, which is the mobile version of React, which was released in 2015. But the framework which really made, which had a lot of success, I would say, on mobile, for the declarative UI framework, which really showed how declarative UIs can really make mobile app development much better than in the classic, than using the UI toolkit. It's Flutter. So Flutter is really what shows us that declarative UIs, it's a great addition to mobile app development. So in May 2019, at Google I/O, Google introduced the new UI toolkit, declarative UI toolkit for Android, JetpackCompose, and the same year in Apple WWDC, Apple presented SwiftUI as the native declarative UI toolkit for iOS. So let's just mention quickly which are some of the characteristics of declarative UIs. So they describe how the UI looks like for the different app states, but they are stateless, so they don't manage the app state directly. And because of this, we can achieve an architecture where the UI layer is neatly decoupled from the view model. And this is showing what I was mentioning previously in the previous slides, that in the imperative UI toolkit, so in the Android view-based UI system and in the UI kit for iOS, we have a middle layer of code that is needed to apply data to a layout, because it's where we actually define the coupling in terms of ID between the data and the layout component. So recently in Android, the things got a little bit better with view binding, but if you think about even in view binding, you still have this layer of code which is needed to apply data to a layout. And similarly, this happens on iOS. You also have a layer of code where you need to define each single IDs, each single components that you have defined in the interface builder. So in the declarative UI is not the same. And you see, if you compare the two. So we have, in the declarative UI, we don't have at all with this extra layer. And we are able to apply data from the view model typically. We are able to apply this data directly on the layout of that we define in JetpackCompose on SwiftUI, and this eliminates a lot of boilerplate code. And this is also one of the reasons why we are able to have the UI layer, which is so thin. So let's talk more in detail about the JetpackCompose. So as we said, it was announced in May 2019 at Google I/O, and it reached alpha last year in August, and is going to reach beta in the second quarter of this year and stable stage by the end of this year. An interesting characteristic of JetpackCompose is that it just requires Android 5, so it's API 21 and later. And because of this, we can say it's backward compatible, because all the new version of JetpackCompose is going to be compatible with the existing devices that have a version bigger than Android 5. This is not the same in iOS, in SwiftUI, because SwiftUI is tied to the iOS framework. So if we want to use a latest version of SwiftUI, we have to target the latest iOS framework. So for the web, the declarative UI we can have for the web in the D-KMP architecture. We can have Kotlin React, because Kotlin is actually providing some wrappers that allow you to use React components even without using just JavaScript. So just by using the Kotlin language, which is very convenient, especially if you already are familiar with the React libraries and components and you want to be able to reuse them. But something even more interesting, which is coming hopefully very soon, it's Compose for Web. Compose for Web is the web version of the JetpackCompose for Android. Development started very recently, just a couple of months ago in November 2020, and is led by JetBrains. So probably the APIs is not going to be identical to JetpackCompose, but we believe they are going to be very similar. So if you think about an app which has an 85% of business logic, which we are already shared, and then the UI toolkit is a 15%. So in Compose for Web, if you are going to reuse a lot of the UI layer that you already developed for Android. So instead of rewriting, of adding a 15% of UI layer, you probably just need to add an extra 5%, because maybe 10% of that 15% is already in common with Android, with the Android UI toolkit. So this is amazing. I mean, this is going to allow shipping a web app very easily, you know, and this is very exciting. And we believe in the future, Compose for Web is gonna compile to WebAssembly, which we believe is gonna be the future of the web. Maybe it's gonna take a while, but you know, the JetBrains team is already starting development for the compiler for WebAssembly. Okay, so in the end, we expect we are going to have two families of declarative UIs, as you can expect. So one is the Compose family, which is developed by Google at JetBrains. And this can be applied to Android, as we said, and to desktop, as recently JetBrains already released a preview for Compose for desktop, which is working in all desktop operating systems, Linux, Windows, and macOS. Then, as we said, is going to be hopefully very soon available for the web, and we hope also for Wear OS and Google TV. And the other family of declarative UI is going to be already SwiftUI, and is already able to seamlessly be applied to all platforms of Apple, iOS, macOS, Swift, watchOS, and tvOS. So let's show very briefly some components that have been written in JetpackCompose and SwiftUI. So here we are showing a component which in JetpackCompose is called raw, and SwiftUI is called HStack. So this is the equivalent in the Android view-based system as horizontal linear layout. So you can see that the concept of JetpackCompose and SwiftUI is really similar. So it's a stateless UI. So you can see you don't see any IDs here, and you can see that with these raw objects and the fields, we are able to apply data directly on the UI component. So text here are elements, text elements within the linear layout. So we have like 3 fields here, and we are able to apply directly on each element without caring about IDs at all. And this is already something that by sight you can see it's very different to the current XML layout in Android, and to Interface Builder, of course, as well. Okay, and so let's talk about the second pillar, which is Kotlin MultiPlatform. So this is a Kotlin meetup, so I expect a lot of you already know a lot about Kotlin, but I think it's useful to review quickly together what Kotlin is. And yeah, especially in terms of multi-platform. So multi-platform arrived experimental in November 2017 in the Kotlin 1.2 version. And at the beginning, it was just adding the support for JavaScript. Then in February 2018, in Kotlin 1.2.20, it added support for iOS. And then in 2020, in August last year, with Kotlin 1.4, reached the alpha stage. And we believe that now, as you know, Kotlin is going to ship regular version every 6 months. So there's going to be Kotlin 1.5 in the second quarter of this year, and in the last quarter of this year is going to be 1.6. So we don't know exactly when the beta or stable exactly are going to happen. And but we believe it's gonna be very soon. It could even be that the stable version would happen in Kotlin 1.6. But in any case, at the moment, Kotlin multi-platform is already, I would say, very stable as a technology. And by using it already into apps, I had really no issues whatsoever. So there are going to be improvement for sure, but most of them are going to be under the hood. So most of the improvements are going to be in terms of the compiler, I guess, in terms of debugging. But for really designing an app and developing an app, you're not going to have many blockers. So you can already really start using multi-platform without worrying at all, actually. So if we compare the timeline with the declarative UIs, we can see that Kotlin multi-platform and JetpackCompose are pretty much in line in terms of they reached alpha version the same time last year in August, and JetpackCompose is going. It seems quite sure that is going to become 1.0 by the end of this year. So by the end of this year, you're able to confidently develop apps with these technologies, with declarative UIs and Kotlin multi-platform. So SwiftUI, while JetpackCompose, when it was first presented, it was presented in experimental. So actually, it was not the source code was actually not even available at the beginning. So it was really experimental. I think, at the very beginning. So SwiftUI, when it was presented already as version 1.1. But if I have to be honest, this version 1.1, it was not really, mature, I would say. But luckily, the year after, with version 2.0, there were a lot of improvements. So I would say that SwiftUI now it's really much, much better, and it's definitely production ready already. And probably next year, this year in June with version 0.3, we are going to see even more improvements, both in stability and probably even in terms of features. So yeah, the declarative UIs, this is the year of declarative UIs. There's no doubts about that. And I would say even the year of Kotlin multi-platform. So Kotlin actually is multi-platform, right? So Kotlin is a language which is developing in a multi-platform way. So we know that Kotlin started as a JVM language, and but now the way that the language is progressing on 3 different, let's say, targets. Yeah, like, because Kotlin can compile already to 3 targets, and one is JVM. We already know for Android, and you can for server side as well. Then you compile to native for iOS, macOS, and all the other desktop platforms. And the third compilation target is JavaScript, which is still not the perfect, but is improving very fast. And then we are going to have probably next year a 4th target, which is going to be WebAssembly. So the formats. So we said that we in our D-KMP architecture we are using Kotlin MultiPlatform for our business logic. So this code that we write for our business logic eventually gets compiled to a library, which is used by our app, which would be Android, iOS, or web. So let's see which are the formats that our Kotlin code is compiled to. So in Android, our business logic is going to be compiled as a jar file. In iOS, as an Objective-C framework, and on web as a JavaScript library. If we compare the D-KMP architecture with other frameworks like Flutter and React Native, here we summarize. So in terms of user interface, as we said, we are going to use the native user interface in our D-KMP architecture, which is JetpackCompose for Android and SwiftUI for iOS. In Flutter, we would use the proprietary widgets, and in React Native the same. They have their own widgets. In terms of business logic, we use Kotlin as a language in D-KMP. In Flutter, there is the Dart language, and in React Native, the JavaScript language. And let's see now how these apps run. So D-KMP apps would run really natively. So they would have a native UI, and they would also have a natively compiled business logic. As we saw before in the previous slide, our business logic in Android is going to be compiled as a jar library, which is a very native, the native way to compile code on Android. And on iOS, and in iOS as an Objective-C framework, which is also a native way to compile code on iOS. In Flutter, it's different because we don't have a native UI, so the UI actually looks the same in both Android and iOS, and is based on a Skia graphic engine. An app of Flutter for Android is actually an NDK app, and on iOS is compiled as LLVM. In React Native, we still use native UIs, which actually one of the main selling point of React Native, at least in the past, which was like the big plus of using the native look and feel. But in terms of performance, it's not really great because the code that is actually running in the app is a JavaScript, which is able to connect to the framework thanks to this C++ bridge. So in terms of performance, there is really no doubt what is the best out of all trees. And also in terms of bundle size of the app file, D-KMP is definitely the best because it's the most native. You know that in Flutter, you always need to add some extra weight in your APKs and in this iOS because you need to import all this Flutter engine, and React Native very similarly. So I think there is not really a comparison in terms of performance and file size, what is best out of these three. So in Kotlin MultiPlatform, some people get confused because they see a few acronyms that the most recent was KMM, which was used recently by JetBrains to define Kotlin MultiPlatform just for mobile. So when you talk about Kotlin MultiPlatform for mobile, you tend to use this acronym KMM, Kotlin MultiPlatform Mobile. And actually, recently, JetBrains, they released a KMM plugin for Android Studio, which is really, really useful and working really well. And actually, thanks to this plugin, we are able to run iOS apps directly in Android Studio. And this is happening because we are actually able to launch the app through Xcode. So, we are even able to launch the iOS simulator directly from Android Studio, but it's actually, the Xcode. So you still need to have Xcode installed, but still it's a very, very powerful plugin, which is really, speeding up development of multi-platform. And we use KMP as an acronym to mean everything about multi-platform. So it also includes desktop and web. So in terms of Kotlin.js, this, as I said, the moment is not really in the best shape. So there's a lot of improvement which are coming up in terms of JavaScript, especially there are lots of expectation for this new IR backend, which is going to be released in a stable stage, hopefully by the end of this year. So this is going to bring a lot of improvement, especially in bundle size for Kotlin.js project. And this is going to be a big milestone for KMP on the web, because at that point, we could really start seeing really good web apps written in Kotlin, and we really look forward for this, and we think it's going to happen by the end of this year. So some of you might question, so when is the best time to ship D-KMP apps, with this architecture? So in terms of mobile, I would say, let's just wait for JetpackCompose beta, which is going to be in a few months' time, and then I think we are fine shipping even in productions D-KMP apps, because SwiftUI is already kind of mature, and JetpackCompose, once it reaches beta, is going to be, I don't think there's going to be any production main issues at all. So I think, yeah, second half of 2021 is going to be good already. So in terms of web, I would say it makes sense to wait for Kotlin.js IR backend, the new backend for Kotlin.js, and also for the Compose for web. But definitely we can already start designing and developing apps. We can already start from this business logic, which is 85%, and then when this we can add already JetpackCompose and SwiftUI, and then when Compose for web is going to be released, we're going to add that on top, just at 15%. So there are no blockers. So we can definitely start using this technology already. So let's now talk about the third pillar, which is the MVI pattern. So the MVI pattern is usually described as an improvement of the MVVM pattern, which is the pattern that at the moment is the most used in Android. So MVI pattern is based on a unidirectional data flow, and on the concept of the single truth for the app state. So the app state is what is the data which are shown on the view, but the app state can only be managed by the model. So the model is the only component in the app which can modify. So the view, if they want to modify the state, they can't directly. They should go through the loop, through the data flow, and through an intent, and then through an intent, we're able to trigger an action that is going to modify the app state, and that modification can then be displayed on the view. So as we say, so the MVI pattern is based on single source of truth for the UI layer, which is the app state, and you can also see in diagram here. And the app state consists of immutable data. This is one of the requirements for the MVI pattern. and can only be modified by the view model. So as you see also in the diagram, so everything is following a unidirectional data flow. So there is a user that is triggering an event from the UI, calling an event which is defined on the view model. Then the view model through the state reducers changes the app state. And then the view is able to display the information that are contained in the app state. So everything follows a unidirectional data flow. And in our D-KMP architecture, what is enabling this MVI pattern is StateFlow. So StateFlow is a component which is part of the Kotlin language, and it's a multi-platform component. So it works on any target of Kotlin multi-platform, and it allows us to have a multi-platform MVI. So typically, as we said earlier, MVI pattern tend to be implemented with RxJava, but we are also able, thanks to Kotlin, to the greatness of this Kotlin language, to have a component which allows us in a very simple way to have an MVI pattern which is multi-platform and basically works wherever Kotlin works, which is basically at the moment really everywhere. And the state flow is what allows the app state to propagate from the view model to the declarative UIs, as you see in the diagram as well. So let's see how the app state is defined. So we assume that an app clearly would have several screens. So the app state is a multi-platform component, right? So is a Kotlin class, is a Kotlin data class actually. And we organize this app state by properties, where each property is contains the data for the state of each screen. We use this lazy keyword, Kotlin lazy keyword, because in this way we just need to instantiate the data for the screen that we actually visit. So let's say we have 20 screens in our app, but in our session we only visit 3 screens, then we would only instantiate this data when we visit these screens. And what about the view model? So the view model, which we said you're going to share among all platforms, which is written in Kotlin MultiPlatform. As you can see, one of the property of the view model is actually the state flow we already talked about, and the type of the state flow is the app state, which is where all our data is defined, the data which is going to be used by the UI layer. But as you see, we define here as a computed property, but only with the getter and not with the setter. This is because the MVI pattern requires data to be immutable. And the modification to this data happens thanks to another component, which is our custom component, which we call State Manager. And in the State Manager, we have the mutable state flow, which is the read-write. Like StateFlow is actually the read-only version of StateFlow. Mutable StateFlow is the read-write version of StateFlow. And thanks to mutable StateFlow, we are able to make modifications. And the other component of the State Manager is the data repository. Then these 2 components that you see part of the view model in our diagram, so events of state reducers. So we define them as extension functions. So events are extension functions of our KMP view model. And the state reducers are extension functions of our state manager component. So you might wonder why extension function and not methods. So the reason is actually it's organizational. So extension function allow us to split methods in different files. And this is very handy in terms of organizing our file system. So we can have in our view model file structure, we can have two folders, one for events, one for state reducers. And each of these two folders, they can have a file which is relative to a specific screen. So we can put, so if we have, say here, in this example, we have home screen, profile screen, and setting screen. So we are able to organize our events and reducer, putting together in the same file those that belong to the same screen. And this is really helpful and can make our structure be very neat. So talking about the state reducer. So the state reducer, as we already mentioned, is what is able to create the new app state, and is able to do that by combining three different inputs, which are user events, so coming from the UI layer, a repository data, and the current app state. So let's make an example. So hopefully this is gonna help us, everyone to understand better. So let's say we have an app with a list of items. So in this case, we have cities. And this could be an Android app or iOS app or web app. It doesn't really matter. And a user click on one of these items, let's say on the city Berlin. So what happens here, that in the UI layer, we are calling an event on our shared view model, and we are passing these parameters, which in our case is Berlin. So this select city is an event, which is an extension function of our KMP view model, as we mentioned earlier. So what we are doing here is calling two state reducers, because by clicking on an item, we are going to load some data, and we are going to expect that it's going to take, and data takes some time. So we are going to use two state reducers. The first state reducer, set loading, is the one who allows to show a loading screen. So what effectively this state reducer is doing, this set loading state reducer is doing, it's flagging one property in the app state. And based on the value of this property, our UI layer is able to show a loading screen. Then we asynchronously call another state reducer, which is the one who's going to retrieve our data from the data repository. And we are setting the detailed data. And then our app is able, and then we are reverting also the other flag is loading back to false. And in this way, our declarative UI layer is able to display the information of the detail. So the concept is really simple, right? So it's a matter of events and state reducers. And each state reducer is going to make a modification to the app state, which is then reflected on the UI layer. So if we see in more detail these state reducers, so what set loading is doing is simply using the Kotlin copy function, is simply modifying one element, is loading, while this other state reducer, set detailed data, is doing something more. So it's actually retrieving data from the data repository, and then is modifying the state in these two elements, these two properties of the state. So if we recap the state about the state reducer, so as we say, state reducer is a state manager extension function, which is taking three inputs. So one of the inputs comes from the UI layer, and in our example, it would be like the Berlin parameter, which by clicking on this element is passed to our event and then to our state reducer. Then another input is the repository, which is actually, as we saw before, is a property of the state manager, is defined as a property. And then the other input is the current app state. So here we are defining a computed property, which is helping us writing better code, because the app state is actually the value of mutable StateFlow. And then with this computed property, we are able to work better, to write a nicer code just by extracting this. And then we are creating the new state thanks to the Kotlin copy function. So in terms of data layer, we have a data repository, which is able to get data, collect data from multiple sources. And these sources could be any kind of data sources, which could be web services, GraphQL, runtime objects, platform settings, SQL databases, all of that. So the data layer is actually what manages the data caching mechanism, and it can apply any advanced logic. And because actually being in a multi-platform space, it means that we are going to write this data layer once for all the platform. So this allows us to have even very advanced and smart and sophisticated caching mechanism. And this is really a big plus for a multi-platform architecture. And what the data layer does is just providing unformatted data to the view model, so to the state reducers of the view model, because the formatting of the data, which we are then displaying on the UI, is happening just on the view model. Then I want to mention GraphQL, which I think it makes a lot of sense for KMP. So GraphQL, I'm sure many of you would know, maybe not all of you, but it's really simplifying fetching data from the server. So instead of developing a web service for each single set of data that our client want to retrieve from a database, GraphQL allows us to define on the client which are the data that we need in our client. So this is really removing a lot of effort from the server, from the web services, and allows us much bigger control in the client. So we believe this is going perfectly in the direction of a KMP rich client architecture, because it's providing more freedom to the client to retrieve all the data required by the server. And it also simplifies, as I said, server-side development, because then the server can just focus on data provision and availability, and we can save a lot of code. And for KMP is already available, still experimental, but already available, the GraphQL Apollo client. And it's a very important addition that we had recently on KMP. So let's see. So in the D-KMP architecture, obviously we are not able to use platform-specific libraries anymore. We are going to use multi-platform, Kotlin multi-platform libraries for all of them. So we are not going to. So instead of using Android LiveData, we would use StateFlow, and instead of using HTTP clients like Retrofit or Alamo Fire, we would use the KMP HTTP client, which is Ktor client, which is developed by JetBrains. So for serialization, we would use Kotlin Serialization, which is also developed by JetBrains. For structured data, we wouldn't use Room or Core Data. We would use SqlDelight, which is being developed by Square. For settings, we wouldn't use the shared preferences and NS your user defaults, but we use multi-platform settings, which is actually a library which is wrapping the existing, on Android is wrapping share preferences, and iOS is wrapping NS user defaults, but this is happening under the hood. So you don't need to deal with a specific API of share of Android or iOS. You just rely on the API provided by multi-platform settings, and you can serve with just one API all the two different platforms. And actually is also available for web, is using the JS storage, so similarly. And for concurrency, we would use coroutines, which actually are already the preferred way in Android, which is replacing the old async task. Okay, so this is the end of my presentation, and I wrote an article a few weeks ago on Medium where I explain even in more detail this D-KMP architecture, and I suggest you to give a read. So it's a three-page article, and yeah, and then this is my handle on Twitter. So if you have any after you read this article, if you have any question, you can tweet me or send me direct messages in Twitter. Okay, so now is hopefully time for question. Hopefully you have some of them. So we pass to Slido. Let's see. Okay, there are already a couple of them. So you mentioned you've used Kotlin MultiPlatform production already. How was the experience? What was the scale of the projects? Okay, so far, the project haven't been really big, but I think I realized with this, I developed 2 apps already with this Kotlin multi-platform, but I realized that it's fully scalable. I cannot foresee any problem of really building complex apps. You can really organize in a very modular way, and I'm very confident that it really applies to any kind of app as well. So organizing states and reducers, why did you go for grouping by state and reducers instead of grouping by screen, having state and reducer? So actually, if you see in, I can go back to my slides. Let's see. Okay, sorry. Go to the app state, which I now cannot find. Okay, yeah. So actually, if you see, it's it's organized by screen. So the app state to start with is organized by screen, and events and state reducers are also organized by screen. If you see here, so we have a folder for events, and we group all the events for the screen in the same file. So the organization is modular by screen, and this can scale very well from my experience. Okay, how do you handle API interfaces like camera, Bluetooth, and native libs yeah, that's a very useful questions. And to answer that, I'm going to show my article where I mentioned that. Okay, so this is the 3rd page of the article I was mentioning. So actually, in KMP, there is this expect and actual mechanism that you see here. And thanks to this expect, as you see here, and actual mechanism, so you can define on every platform some specific codes which you can refer to from the common code. So let's go back to this. So let's say, in case of Bluetooth, right? So you would have, for Bluetooth, actually, there is already a KMP library, as you can see here in my article. So there is, recently, there's been released this library, which is a KMP library. So you can use this library. It's called Cable. So you can use this library directly on your common code, and you don't need to care about Android and iOS implementation, because this library is already doing that for you. But even if this library would not exist, you would be easily able to do it yourself, thanks to this mechanism, which is the expect actual. And in this way, you would have the platform-specific implementation in the actual implementation, and then you could connect to this code in the common code, and yeah, it works really well. I mean, Kotlin multi-platform has really been thought in a very good way, and I think it's really an amazing technology. I'm really happy.
Okay, I think that's it for the question. Daniele, thank you so much. That was a really great presentation. Hopefully you can, there's a lot of research there, and I think it's going to become quite a reference for a lot of people. So thank you.
Thank you.
And we hope to welcome you back another time. So appreciate it. Okay, next up we have Mohit Sarveiya. And I think, Mohit, once you're ready, I think you just go for it.
Hi, my name is Mohit Sarveiya. I'm a GDE in Kotlin, and my presentation will be on Micronaut. I want to first, before starting, thank the organizers and Kotlin London meetup for the opportunity to come back and present. It means a lot to me. So in this presentation, I'm going to, show you examples of how to build APIs, REST APIs using Micronaut. And I'll show you how coroutines are supported, how to use them with Micronaut, and how to set up database access and setting up retries, and lastly, how to do load balancing. So what is Micronaut? This is a JVM framework, just similar to Ktor and Spring. And this framework was built by Graham Rose, who is the creator of the Grails framework. And when he built this framework, he applied many of his learnings and his experiences to build this Micronaut framework. And it's a polyglot implementation, meaning when you build your microservice with Micronaut, you could choose Java, Kotlin, or Groovy. So this framework is open source, and it has many benefits. And the benefits that it has is that it's fast. It's fast in startup and has a small memory footprint. It also allows you to do meta programming, which I'll show you. And you could, using annotations, set up different, configure like retries, and configure different things. So Micronaut, the core architecture is built using RxJava. And so it's reactive, but doesn't enforce it. If you don't want to use the reactive side of Micronaut, you don't have to use that. So it also has ahead of time compilation. So other frameworks, at startup, they will, you do bytecode analysis to learn about the setup of your project. But Micronaut at compile time, it generates meta information to understand the setup of your project, which makes it really fast at startup. So these are the benefits of using Micronaut. So how do you create a Micronaut project? I want to show you now how to build simple applications using Micronaut. And there are 3 different ways to create a Micronaut project. There's a plugin in IntelliJ. There is also a command line tool that allows you to create different parts of your project. You could also use this Micronaut launch is part of the Micronaut website, and it allows you to configure and specify dependencies that you need, and it will generate a zip file with your project that you could use. So for our examples, I'll show you how to use the command line tool. So the command line tool, you could download it using an SDK manager, and the command line tool has different commands to create scaffolding for different things like controllers, beans, and clients, and I'll show you how to do that. So here's an example of using, let's look at an example of using this command line tool to build a simple Hello World app. So when you download the command line tool, you could do it using, I believe, Brew, and also the SDK manager, and it's called MN, stands short for Micronaut. And it has a command called create app, but there are also different types of other commands. There is a command to create a CLI app or gRPC app or a messaging app. So all these different commands set up just starting code for that you would need for that particular type of app. We'll create a very simple REST app. So as I said earlier, this is a polyglot implementation. So you could specify which language you want to use. And by default, it will create a scaffolding in Java, but you could use, you could specify Kotlin or Groovy. So, and then lastly, you specify the package name, which is Micronaut app, and it will use that package name and build an app with it. So this is what it builds. It's a very simple structure. So this is a Gradle project that it's going to build. You could specify it to build a Maven project if you want. So it has a Docker file and it has a very simple source set. So in that source set, what you'll see, what it will create for you is an application object. Whichever application you have, obviously you have to start it up at some. You have to have some entry point of your application, and this application object just has a main method that builds your Micronaut app, and then it starts it up. You specify a package name. So this is the starter code that this command creates for you, and we're going to use this and build on top of it. So suppose we want to build a very simple REST API that has a GET, and you go to this URI and you give it a name. And what it returns is a greeting, hello, and whatever name you passed it. So this is a very simple example of how do we implement this using Micronaut. So to implement this, what you need to create is a component that's able to handle any requests from the client, any requests to that URI. And this tool, MN, allows you to create has a command called create controller. And what this controller, to use this command, you give it the name of the controller that you want, which is in our case called greeting. And what it will do is create basically two files, the controller class and a test for it. So these two files that it creates for you has some starting code that you could build on top of. For our approach, what we're going to do is what I want to show you how to do TDD, test-driven development. How do you start from the test for our example, and then write our logic in our greetings controller. So let's look at how to write a test for a simple example. So in order to write a test, every test starts with this annotation called Micronaut test. What this annotation does is that it sets up the application object for your unit test. And the next thing that we're going to do is inject an embedded server. So this is what's great about Micronaut. This embedded server will spin up that you could test against in your unit test, and you could do like TDD. It allows you to do TDD with this. So in my test, what I need to do is specify a client. I'm going to create a client that's going to interact with that embedded server, and I need to specify in my client what URI am I going to test? Am I testing against? And I'm testing against this URI here, greet, and the name that I pass in. So what the add client annotation does is that it creates all the scaffolding, the boilerplate code to interact and make this request, to make this client. So Micronaut has dependency injection, and using dependency injection, I'm injecting this greeting client here in my test, and then I have a test in which I'm going to do an assertion that I get what I expect. So I'm going to call this greetings method with the Micronaut string, and then I'm going to do an assertion that it should be equal to greetings Micronaut. So when my client makes a request, that's what I expect my result to be. So I have my test. Now what I need to do is write out the actual logic that this test will run against in my controller. So in order to create a controller, when a controller gets created, it's all annotated with this add controller annotation. And at build time, what that does is generates code to be able to handle the routing to the different methods in your controller. So in this controller, I'm going to handle and add logic to be able to handle this URI, greet, and the name that you pass in. I'll have a method that basically takes that name and it returns a simple string. So greetings and a string template and greetings in whichever name you pass in. So this is a very simple example of a controller. And I can run my test against, when I run my test against this, it will pass. So what I have done, so the great thing on Micronaut is that you could do even really easy to do test-driven development. So when I run this, I can run this in my browser, and by hitting this URL, so the port is always defaults to 8080, and I could hit that URI, and then I'll get a response back as I expected. So this is that was a very simple example of creating a Micronaut project using a command line tool. A very simple example of just a hello world example of creating a controller and unit testing it. So let's build on top of this knowledge and look at how to use coroutines. So coroutines are so Micronaut has support for Kotlin coroutines, and you could utilize these different things in your controller. You could have suspending methods. You could also create your own scopes. You could specify that a specific method in the controller should utilize some dispatcher. And you could also build reactive APIs in your controller, have your controller return a flow of items. And let's look at each one of these and how to use it in your controller, in your REST controller. So as I said earlier, the core of Micronaut, when you look at the code, it's built using flowables or RxJava. But there's a bridge that's built on top of it that provides coroutine support. It provides support for using flows, and we'll look at how this bridge is created. So but we just go back to this simple example we had of a controller. How suppose that I wanted to change this to be suspending, Although in this example, I'm just returning a single string, you may be doing some IO operations and you want this method to suspend until that's complete. So the Kotlin library provides a keyword called suspend that I could append to this. So and this marks my method suspending. Now the question is, how does Micronaut understand what this suspend keyword is when it encounters it? So when you look underneath the hood in that core architecture Micronaut, what you'll see there is a router. And the router goes through and looks at the different methods that you're using in your controller. It sets up a deferred flowable. So the core architecture of Micronaut is written in Java. And what it does is that it looks at the methods and it checks whether you have a method with the keyword of suspending. And what if you do, it knows how to handle that. And it has a method to be able to execute that type of suspending method. So how does it configure or handle that suspending method? In that use case, what it does is that it sets up a publisher. And what it does is that it looks at your suspending method and then checks, is your suspending method actually returning a type? If you are returning a type, then it creates a publisher from a completable. Thus it creates a flowable by utilizing this approach from a completable. Otherwise, it sets up a completable future. So this is the bridge basically that understands how to handle that suspending method in the core layer of the Micronaut architecture, and it sets up this flowable. So that's how suspending methods are supported. So the other thing is that you may have a scenario. So I had a suspending method in my controller. I may want to execute the logic in there in a separate dispatcher. How do you do that? So what you could do is that in your method in your controller, you could inject an executor service like this, and then you could get a dispatcher from there. So as coroutine dispatcher, an extension provided to you from the coroutine library, and it creates a dispatcher from that. And what I could do is create a coroutine using with context. And with context internally starts a coroutine, creates a scope on the dispatcher that I provide there. With context you have the ability in with context to return the result of some computation. And that's what I could do in there. I could do an IO call and take the results, process them, and return them. And that coroutine will execute on that dispatcher. Everything in there will execute on that dispatcher. So another thing that you may want to do is create your own scope. And you could do so in a number of different ways in your controller. You could create a scope on that dispatcher as a field in your controller and launch coroutines off of that. You could also create a scope using this coroutine scope builder, and this internally creates a scope for you, and everything in the Lambda block will execute on that coroutine. So the other thing that Micronaut supports are flows. So, what I showed you so far are just examples of a controller that returns a single value. But you may want to create a stream, a JSON stream, for example. And you may have a use case where you want to emit like at different times depending on your use case. So how do you set that up? So suppose you have a server and you want to emit basically a series of items to the client. And you could create an endpoint like this. Here's a simple example. Suppose on the back end you had the stream endpoint the client would hit, gives you a flow. How do you implement that? So to implement that, I have created a method here called stream, and its return type is a flow of int. So here's a very simple example, and where I have a flow of 1, 2, and 3, and I'm calling the on each, there is a delay extension, but it was deprecated. So what this does is that every time something is emitted, before it's emitted, it delays, and then it emits something. So I have set up a simple flow here. And now suppose on the client side, I were to call this URI. What happens? So when I call this on the client side, I'm not going to get any type of data at all. Just going to get this empty JSON object. So the reason why is that there's a piece that I'm missing that's very important to remember, is to add basically a bridge, this module. So the Kotlin Coroutines library has modules for testing, but it also has these reactive modules. And what it's for is for interoperability between coroutines and RxJava. And they have modules for RxJava 2 and version 3, and also reactor modules. So you want to include that as a dependency. So when you include that, and the reason why is that because there is in the core architecture, there is a bridge that hooks for understanding how to work with coroutines and flows. So when I include that, you'll see that, and I run my code, you'll see that I get a chunked response. I get a response, and I get a stream of values now that I expected. And the reason why is that, like, underneath the hood, this right here is the component that makes everything happen. This is a registrar, and what it does is that it basically checks if you're using a flow. If you're using a flow, you'll see right here this is Java code. So As publisher is an extension on the flow provided to me by the Coroutines interop library. And it's calling that method to set up a publisher from this flow. And it's doing React Native Flow KT. So it's calling that, it has to call the extension in a static manner because this is Java. So this is right here, the bridge that basically that understands how to hook up flows to publishers. So this is how coroutines are supported in Micronaut. If you don't want to use coroutines, you could also just use RxJava if you want. So let's look at now how to set up database access. That's built on top of everything that we learned. So in a real world application, you usually have some an API does some CRUD operations in some particular database. So let's look at how to set that up with Micronaut. Suppose we want to build a very simple API. This is an API that could list tasks. That could basically, you could get information about a particular task based on an ID. You could also create a task, do a post request, and the client could send in whatever the description of this task is. You could also update an existing task that you want, and this is a put request. You could also delete a task. So this is a very simple task API. How do you create this, implement this with database access using Micronaut? So in Micronaut, so you usually have you have your server that communicates with some database, and you could have, for example, you could have a middle layer like Hibernate, which is an ORM that you could use that provides an entity manager to be able to interact with your database. And let's look at how to utilize that. Not everyone takes this approach. You could also take other different approaches if you want in terms of interacting with the database layer. You could also just write SQL queries yourself if you want more control. So first thing that we need to do is to create the task data class. Now, using the command line tool, there is a way to create a bean, and it sets up everything for you. So this is a data class, and it has an ID. Each task has an ID, and it has as a description. So when we create this task, I need to be able to set up a schema for my database, and I could do that using the add entity annotation. And I could say that the table that I want to create is called task, and I want the ID field to be the primary key, and I want it to increment every time that I do an insertion. So I'm using annotations to configure this. What I could also do for the description column is to specify what is nullable or unique, give it a name for it for my database schema. So what I've done so far is specify the task table. And now what I could do is set up a repo to interact with this database. So let's look at how to set up being able to get information from the database of a particular task based on an ID. So I'm going to create a task repository. The repository, I'm going to inject an entity manager, which has an API that allows me to save, create, etc. So if I want to find basically information about a task based on an ID, I could use this method on my entity manager that give me a task type based on an ID. That's very simple. But suppose I want to create a task. In order to create a task based on a given description, I could basically create a task object, and then I could say to my entity manager, persisted, do the IO operation, persist this task on the database. So I could also update a particular task. And this is a good example of how the entity manager supports writing custom SQL queries. So what I could do, basically, given a task ID and a new description, I could create a query. It basically goes into the task table and just searches for a row with a task ID and updates the description column. So I could give this query to my entity manager, and I could set basically all the parameters, task ID and description, and tell it to execute and perform the IO operation. So lastly, suppose I wanted to delete a particular task. I could also do that using the entity manager by using the remove method in my repository. So what I have so far is a very simple repository that knows how to communicate with the database. But I know now I need to create a controller that uses this repo. So I'm going to create a task controller, and I'm going to inject this repository in there. And this annotation controller allows me to specify like a base URL that this controller will handle. It will handle URIs with this starting base task URL. And I could specify using this execute on basically all the work that this controller will do. I want it to run on this executor using the execute on. So suppose I wanted to implement basically getting information, this URI here, getting a task based on an ID. And what I could do is just delegate to my repository to give me basically a particular task based on an ID. So what I could, after that, suppose I wanted to handle requests like the post body from the client. So what I could do in order to handle that is that what the client gives me, the description that the person wants to create a task for, I could encapsulate that into this data class, a command. And then what I could do is that the client for this particular information give me a string, or it could give me an empty string. And on the server, on the client, on the controller, I want to be able to handle basically sending error responses and be able to do validation based on what the client gives me. So, and I could do that in my controller. So the way that I could do that is by setting up constraints. And I could set up a constraint as I did here at field. I want this to be not blank. There are all other types of constraints I could set. I could set like a regex that I want for a particular field. And then I'll mark this data class with intercepted, and which at build time will basically generate the code to be able to, do this validation. So in my controller, I'm going to give this task save command. I'm going to have this command. And there's an annotation that hooks up being able to validate this this command. So one thing to note here is that with Micronaut at build time, this will generate basically it will subclass this class and add in logic to do this. The one thing to note here is that you will have to mark this class as open. Because in Kotlin, as you know, classes are final by default, or you could use the all open Kotlin compiler plugin. So when you create your project, it actually will add that all open plugin for you. So the way you handle save is that you give it to your repository, the description, it will create it. Now, after the IO operation is done, you want to be able to, you may want to set up the headers and be able to send certain status code or errors. Suppose I want to send a 201 back to the client. So there, Micronaut has an HTTP module that provides you with an API to do this, set status codes, update headers, send errors, etc. So for this, I could use this method, create it, and with this HTTP response, this static method, and pass in this task. What this will do is that when I create a task, it will return me the new task that was created as JSON. I could also delete a task, handle that. So suppose the client gives me a task ID to delete, and I could pass in no content back to the client. There's a method that on the HTTP response object that allows me to specify that. So so that's a simple way to be able to create a controller that handles, sending back responses to the client, to be able to handle validation also. So if I suppose that, as I'm developing this, I didn't set up my database. And what will happen is that, when you go in about testing this as you're developing, it will use an in-memory cache rather than a database. It knows how to detect whether you have set up a database or not. And you'll see it in the logs. You'll see that if you don't have a database set up, it'll use an H2 dialect. If you had a database like Postgres, it'll just use a dialect for that. So the way you configure which database you want, if you want to do any type of configuration in a Micronaut app, there's a YAML file that's created for you. And inside of that file, you could set up basically, you could change the port, set up whether configure Hibernate and set up your database sources. Like what I have done here is set up the URL, username, and my driver. So when I call this URL, you'll see is that I get, suppose I want to do a post request and send this description. It will, my controller will send me back what was created on the back end. So I could also get a list of all the tasks that I had created in a JSON array, and you'll see in your controller, like the annotation, get annotation, you could specify like different types of application types if you want also. So now suppose that I made this and I want to quickly be able to test, create a really simple client to be able to test this API, similar to what I did in my unit tests. So there's a command line tool to be able to create very quickly a client, simple client, and it basically creates a runnable. And inside of there, you could basically create a client to be able to ingest your API to be able to test it out. And the way you do that is that this tool has this command, create CLI app, and you provide it the language and the package name. And what this will do is create the scaffolding, minimal code that you could use. So inside of the way I could set up my client is in a very similar way to did in my unit test. I have this interface and I want to test. I want to try out this get task URI, or I want to try out being able to save a task. And then this will create all the scaffolding, it will create a client for you that you could then use. So you could inject this client into this runnable and just test it out by running it, calling the get task method, and you'll see the request back. So this is a simple utility to be able to quickly test out, command line utility to be able to test out your API. So in summary, we looked at how to build a very simple task REST API. We looked at how to use Micronaut's HTTP request and response API, set up database access, and create a command line client. So the other two things that I want to show you is how to set up circuit breakers, which are a way to be able to do retries, to be able to do backoffs. So there's a possibility when you call a particular method that there's a possibility it throws an exception, and how do you basically retry when that happens? So on the client side, using an annotation called circuit breaker, I could basically set up the number of retries I want to do when that happens. I could set up a delay basically that I want to delay for a certain time before doing a retry. So I could set that up on my client to do 5 attempts in this example and delay for 1 second, before every attempt. So with this annotation, you'll see you could test it out in your command line client on how that functionality works. You'll see it work in your logs. So the last thing I want to talk about is load balancing. So Micronaut has built-in support for load balancing. It supports very different types of load balancers, and you could configure them. So you usually have like multiple servers, and you want to be able to manage the load. And by default, like Micronaut uses round robin strategy, but you could implement any different type of strategies that you want. So to set up load balancing, like one thing that you could do, an example I'll show you, is that you could set up, you could configure in your YAML file, application configuration, some console, for example. Console is a way, it's a service that open source that allows you to, it provides load balancing, and you could set up registration for all your when you start up your servers, all your servers will register to this console service. You could configure that in your Micronaut application. So, and you'll see, as you see here, it will register with console. You could also, to be able to use any type of port, you could do, I didn't show this here, you could do port -1 to be able to for it to randomly select a port. So, by default, the load balancing strategy would be round robin, but you could inject and configure whichever that load balancing strategy that you want. Micronaut has integrations for different types of services. So that was my presentation. I hope that was helpful to you, to give you a good starting point on using or playing around with Micronaut and building applications with it. So I want to provide you, I'll link out in my slides, some resources. There is a resource, lots of YouTube videos from Graham himself, the creator of Micronaut, and he explains much more in depth on the motivations, and check that out. It's on YouTube. Also, wrote a lot of, gave a lot of talks last year on coroutines. And if you need help with coroutines, or you could check out my talks and blog posts on my blog post, codingwithmohit.com. So the other thing is that if you're looking for coroutine training, if you're looking for training a team, or if you're looking for learning how to test things, I could help out by tailoring a curriculum to help you to learn coroutines and provide one-on-one coaching. I have extensive experience on using coroutines on backend on Android, and please DM me on Twitter, heyitsmohit.com, and be happy for mentoring, and to be happy to help you to learn and use coroutines on your team or individually. So I want to say thank you to the organizers, Enzo, Amar, and everyone. It just means a lot to me to present again here at the Kotlin London meetup, and I hope my presentation was helpful. Thank you.
Great. Thank you, Mohit. So we didn't have any, we do have a question. Does Micronaut support application profile like Spring Boot app? How would the mock external system dependencies and injection work in testing?
So does Micronaut support application profile? So I'm not 100% sure on that, but you could check out the website, which will have more information. I apologize, I'm not sure if it has that support. How would the mock external work in testing? So when you create your Micronaut application, it will set up all the testing dependencies for you. Yeah, that's if you want more information on that, please in the Kotlin language Slack community, there's a Micronaut Slack channel with Graham. If you have any more questions, please, if you want more information, please feel free to ping that Slack room.
Great, thank you, Mohit. And just to remind viewers, also Mohit's previous talk is on our YouTube channel, so do check that out as well. Mohit, thanks again. And that's a close for today. Thank you, everyone. We'll be back on the 3rd of March. Thanks again, Daniele, Mohit. Great talks, great presentations. and we hope to welcome you back soon. And remember, of course, you can watch all of our talks here on the YouTube, so please take a look, please subscribe, and let us know if you like something or don't like something. And from myself, Guillermo, Pablo, Enzo, stay safe. See you next time. Thank you.